Ohm's law was discovered by George Simon Ohm in 1789 and is still today one of the most fundamentally practical equations. Ohm performed experiments on several conductors and found that each had some differing level of resistance. Ohm's law states that the current in an electric circuit is directly proportional to the potential difference and inversely proportional to the resistance. The Ohm's law equation has three variables: potential difference, current, and resistance. The equation represents the relationship between these three components within an electrical circuit. The potential difference of a circuit, measured in volts with the symbol V, sometimes E, is defined as the amount of energy that charge carriers hold between 2 points within a circuit. The most common source of potential difference or power supply used in circuits is batteries. Current is the second variable, measured in amperes with the symbol I, is described as the rate at which electrons flow past a point in an electrical circuit. Current is induced when a potential difference is connected to a pathway for the electrons, usually a copper wire. Finally, the resistance of a circuit, measured in ohms with the symbol omega, is defined as the property that resists the flow of electrons or current through a circuit. To explain Ohm's law, we can use this diagram of a water circuit. The water pump acts as a power supply, pushing the water, i.e. the current, around the circuit. When the water pump has a higher power, it can push the water around the circuit at a greater rate. However, when the water approaches an obstruction, i.e. the resistance, the flow of water reduces. This same principle occurs within an electrical circuit. Here we have an example of how to use Ohm's law. As we can see in the diagram, the only elements we have a magnitude of is the potential difference and the resistance. However, we are still able to obtain a value for current by doing a simple calculation using Ohm's law. Using the formula V equals IR, we can rearrange for current to be the subject and substitute in our values for potential difference equals 12 volts and resistance equals 5 ohms. Completing this calculation, and we can obtain that the current in this circuit is 2.4 amps. Using multisim, we can check whether the value for current was correct, and as seen by the simulated circuit, we can verify Ohm's law. We can also rearrange Ohm's law and sub in our new value for current to verify that it was correct by performing two more calculations. We obtain our original values for potential difference and resistance, which verifies Ohm's law further. Ohm's law has been used for over 2 centuries and still has a large relevance today. Whilst we have only used it for circuits, it is used to calculate output for a range of equipment, including heaters, kettles, and even laptop chargers. These are all governed by the principle of Ohm's law.